Yep. Hello. How you guys doing? First of all, this is the outline. I'm going to talk about what Stan is today, some of the Stan ecosystem, how we got here, and just some fun tidbits. Disclosure, this is going to be very Stan core-centric. I haven't been on the periphery of Stan for a while. And this talk is going to be the fluffiest talk in the whole conference. And yes. All right. Just a quick show of hands. Who started using Stan in 2017? Whoa. Awesome. Thank you for coming. Who started in 2016? 2015-ish? 14? 13? Whoa. 12? There's a couple in the back, and 11. That's me and Bob and Ben. This is amazing. Thank you for coming. It's really awesome seeing an event like this turn out well. All right, so today Stan is almost 1,600 days old. It's like 4 years and change since version 1.0. We've had 32 releases since we first launched. The first one was in August 2012. And the latest version was December of last year. We've been cited in about 1,500 papers. It's really hard to count citations now. At first, we were really happy when we saw the first paper using Stan, and I couldn't find it anymore. But now we've got about 1,500 people. People are using it to benchmark their own packages, which is kind of trippy. Like, we built something well enough for other people to try to benchmark against. It's used in textbooks. BDA 3 is now with Stan code. Statistical rethinking, doing Bayesian analysis. Gelman and Hill version 2 is going to have Stan in it. It's used in academic research. Who here is using it for academic research? About half, more than half. And industry? That's a good, yeah, cool. So it's used everywhere. It's really awesome. The Stan ecosystem, right? Today, this is Stan. We have the math library Stan. We have the interfaces, command Stan, PyStan, RStan. We have things built on those. So these are also interfaces up here, MATLAB Stan, Statistan, so on and so forth. We have Profit built on PyStan, and now I found out it's also using RStan. RStan ARM, shall I say? I didn't even list all the packages that are going down in this R route. And then on top of that, there's the Stan mode and example models. There was a simpler time, though. August 30th, 2012, version 1. We just had Stan. Now, this isn't quite accurate. If we were to look at it now, it's really the math library, the Stan library, which is the language and the algorithms. Command Stan and RStan were also in the same repository. But it's a lot simpler than this, which is kind of cool. So how do we get here? Before Stan, there were already languages for specifying models. Bugs was out, JAGS was out, Infer.net was out. We used Elmer and Glimmer. You could have coded your models in C++ or some other lower level language. Hamiltonian Monte Carlo wasn't quite a new thing. It was already described in many textbooks, so it was there. Automatic differentiation and symbolic differentiation, those weren't widely used, but they were still there. We had played with Staccato for sure. We tried using Boost when we started. So how did we get to where we are now? In my opinion, it was really these three things. We did some things that are really cool technically. We focused on solving a problem, and we ended up with a great community, which you're all a product of. So the technical progress that we made by version 1.0, we had a Stan language. That's thanks mostly to Bob. It's Turing complete, and the cool thing was that everything in that language could be auto-diffed, right? So anything you write there has derivatives. The second is we had to write our own auto-diff package that was flexible and fast and ended up being pretty fast. And then the third thing there is that we had to make an improvement to algorithms. HMC is actually very hard to tune. If you look at Matt Hoffman's original NUTS paper, we show the Gibbs sampler versus HMC versus, or sorry, MCMC, sorry, Gibbs sampler versus random walk metropolis versus HMC versus nuts. But there's another set of graphs there that are very important, which are HMC tuned to the right parameters versus nuts. And nuts allows us to run an algorithm on a lot of different problems without having to tune. And the fourth thing that doesn't get talked about a lot, but I think is really important, are these transformations that allow us to sample from an unconstrained space very easily. Yeah, that's all described in the manual, so if you have any questions about that, it's all written out. So that was the technical stuff. We focused on solving a problem. The first thing we did was we ate our own dog food. I remember Andrew was starting to write models in Stan before it was really ready to go. And Andrew really insisted that we didn't release Stan until Stan was faster than JAGs, and there was an R interface. Those are the two commands he gave us. Like, you cannot release until those two things happen. And lastly, the thing that we really developed was a sense of community. If you've been around on Stan users for a while, it was awesome seeing all these different models. It was really eye-opening. And then we had Stan Dev, which was for the developers, and we kept everything open and discussed all our decisions out in the open, tried to invite other people to help contribute, and now we've moved on to discourse. So for the community, as developers, we've always valued openness. The Stan Dev Google groups is still archived and online, and you could see us either bickering about things, trying to figure out compiler messages, when to release, when not to. And we've moved that to discourse, and we also value being helpful. We invite other people to contribute to Stan. We really enjoy that. And we couldn't have built Stan without a team, right? So this is a team in order of joining the Stan development team, which is a very informal process. This is something that the members of the development team probably haven't seen. I pulled out the first commits to Stan. And so Bob was the first one to commit, then Matt, then me. Ben joined in January 2012, and so on and so forth. But you can see towards the end, Charles is up there in 2016. We got Sean Taltz in 2016, and Ben's also here. The team that's here at StanCon, can everyone wave real quick? Come find these people during the breakout sessions. I think everyone here likes talking to people. I might like talking to people less than other people, but that's okay. But please, come bother any of us. We're all pretty friendly. Okay, so that was up to Stan 1.0. So what have we really focused on since then? I would say it's a lot of language expansion. We added functions, user-defined functions. Ordinary differential equations are a game changer. And we're just expanding the types of models that you can fit in it. We worked on speed. Most of the underlying code we just try to optimize as we go along. Since version 1.0, we've added optimization, so that's LBFGS, BFGS. We've added ADVI, which is an approximate Bayesian algorithm. Michael Betancourt added a new version of nuts that's in Stan now. We're continually working on usability as well, and you can see that through the R packages, the Python packages, and this whole other ecosystem that is growing. And we've managed to build up this really robust user community. I mean, how many of you have gone to the discourse forums and posted something and gotten a response from someone else or Bob? Yeah, pretty much everybody. And it's really amazing. I really like the developer community. It's a place where I feel like everyone there is there to learn something and contribute something, and no one has all the right answers. Okay, so let's move into some fun bits of history. So we released version 1 in August of 2012, but we thought we were ready in early 2012. And I'll show you that. The first commit here, this is Bob's first commit message, and that was in April 2011. This is an email from April 28th, 2011, and it says something like, I think Stan will be ready for release in a few weeks, and it didn't happen for another year. That's fine though, right? At this point, we already had autodiff. We already knew that it was fast, and we had implemented a lot of things that we needed. Fast forward a few months to October, and we had an end-to-end demo of Stan. And I coded up a simple Stan program, the bugs examples. And here's Andrew saying, that's great. Once it's in R, we can ship it. That was a recurring theme for how long, Bob? Doesn't exist until it's in R. All right, so the manual. In version 1.0, it was 178 pages. I reread it recently while preparing for this talk, and it was actually still well written, and now it's 620 pages, but we've been adding, mostly Bob.
Lots more since then. Charles just rewrote the GP chapter.
Awesome.
No,
Rob.
Rob rewrote the GP chapter. You should rewrite the ODE chapter. You have a bunch of examples.
Anyone want to see the first Stan demo? All right, here we go. Let's see. Hang on, can't exit. Can anyone see that? So this was the first Stan demo. You can see there's no language. We had, for those that were in my little tutorial this morning, we still had the same structure. We had a log probability function. Look at that, it's not even templated at this point. Is it? No, it's not templated. That's cool. Yeah, that's right. Yep, and we could see it run too. That was it. That was the first demo that I could find of Stan. And so it was actually drawing from bivariate normal distribution. It was trying to estimate the bivariate normal distribution. Okay, where'd this presentation go? All right, do you want to see a second demo? Let's see. 8 schools. So this was 8 schools, right there. It's really hard to make the font bigger. That's the log probability distribution function that we defined in C++. You see the theta, you see the normal distribution, or the incrementing the log prob. If you look at this, you can see why we were thinking about incrementing the log prob. This is sort of what Stan will generate nowadays. Okay. You want to see the first Stan program? The actual Stan program? Yeah, this was it. This was from October 2011. And this is the rats surgical example from the bugs library. And if you look, it looks kind of similar, but check that out. We used to have doubles in there, and the bounds were written out that way. By version 1.0, we had changed to something that looks very similar to what we have now, and it's been that way. We sort of deprecated that left arrow from R. And I think the only breaking change was the LP __. But otherwise, the language has stayed pretty much the same. We've added a ton of features like functions and ODEs. I'll wrap it up, some key takeaways. Stan is rad, and the development has really been a team effort. We really couldn't do this without people contributing. So if any of you want to join us, please do so. We have an awesome online community, and if you're not familiar, please go there, hang out. It's cool. And thank you.
Okay, questions for Bob has a question?
I have a comment.
Okay.
So I think the one thing that Daniel didn't mention that's been really important in an ongoing basis is all the refactoring work. So we're on the third major rewrite of Stan. This has been transparent to users because we've tried to keep everything backwards compatible, but Daniel's actually been the one doing most of that giant refactoring. So thanks. You need to do this. The general rule in software is the third version, you finally figured out what you should have done in the first version. Hopefully we're there. So.
Slick Stan. Other questions?
Joe's got one up here.
Yeah, without undue modesty, how do you think, without undue modesty, how does Stan compare to alternatives? What do you look at when you're developing that you see out there in the wide world that you want to incorporate in Stan?
Do we see when we're developing? That's, we're trying to do things with GPUs and MPI. That seems like it's an obvious next step. In terms of the language, I was actually thinking about it, and I wouldn't break it apart in any other way. There might be a more clever way to do that. I don't know. Yeah, why don't you ask people at the break? That one's a complicated question.
Thank you.
Anyone else?
Any other questions? Okay.